All right, this will be a slightly longer SageMath video. We're going to talk about checking if a number is prime. We're going to talk about for loops, and we're going to talk about factoring in Sage. So let's start with the built-in functions, factoring and checking if a number is prime. So let's look at a number that factors, let's say 12, and we want to know, does it factor? So what we're going to do is we're going to pass the factor method on the number 12, and we'll see 12 factors as 2 squared times 3, which is its unique factorization. Um, and we can look at maybe a prime number, let's say 17, um, which is of course prime, so the factorization just involves 17 itself. And so we could find the factorization of of an integer into its into prime powers by the dot factor method. We can also check if an integer is prime, and in Sage, if you want to know if something satisfies a definition, usually the method that you pass is and then underscore whatever you're checking. So is prime is, well, self-explanatory, but this is the general syntax. So is underscore and then definition that you're checking. So is prime true? If we go to 12, it'll say false. Great. So we can factor and we can check if something is prime. And actually, if we factor and there's only one factor that shows up, then it's clearly prime. So they're somewhat related. I want to check. I want to look for the first 100 prime numbers. Let's say. So we have to start our count at 2, or rather, let's look at all the 2-digit primes. Okay. So we want to find 2-digit primes. What are they? Okay. So let's do that. Now, to do this, we're going to run a for loop. So a for loop, what it does is it's not like an index sum. You do one I value. So for I, a specific I value, we're going to do something, and then you increment that I by 1, and then you do the next I value, and so on. So we're going to say for I in range. Let's see, we want to start off at 2, and we only want um, 2-digit numbers. And actually here, what we're going to do is we're just going to print out I, and we're going to see what this gives us. So for I in range 2 to 100, what happens? All right, so that's a big, long list. And notice that it stops at 99. So it started at 2, and then it stopped exactly at 99. So what that's saying is when we use this this range command, range function, however we want to say it, the left-hand number is inclusive and the right-hand guy is exclusive. So this is going to be all the possible primes in the range, in the 2-digit range, up to 2 digits. Okay, so now what we're going to do is we're going to ask, is I prime? And we're going to print that out. Now this is actually going to error out for us, or at least it did for me earlier. All right, so here, int has no attribute is prime. What we have to do is we have to specifically say this is an integer. So surround I by ZZ. ZZ is Sage for integer, and then put that in parentheses. And then after we do that, this converts it to something that the isPrime function understands. Then we pass the isPrime method to it. Okay, so you'll notice here that this is not helpful at all. In particular, we can see a bunch of trues and falses. 99, this last guy corresponds to 99, so that appears to be not prime. In fact, it's 3 times 33, 98, and so on. So this is not super helpful. What we would like to do is to maybe even print the value I itself. let's see. Let me write it like this: print I, and then print this. So this will give us the value I, and then whether or not it's prime. So 2 is prime, 3 is prime, 4 is not, so false, and so on. And it will go all the way up to still 99. Now this is not super helpful because, well, we only wanted to find the prime numbers, so we don't really care about all the falses, right? So what we're going to do is we're going to do a little bit more logic. We only want to output our I value if the condition ZZI is prime is true. And as mathematicians, we know how to deal with that. If this is true, print I. Okay, now you'll notice a couple of things before I do this. You've already noticed. When I put this colon here, that's saying, do something for I in this range. But you'll notice that an indent happened. I didn't do that. That was done automatically. And this is a feature of Python. Well, this is a property of Python showing up. Namely, it has to be properly indented for the syntax to be correct. So if on your end it's indenting, that's completely normal. And if it's not indented, that's a problem. Okay. All right, so let's check this. So what should happen if this is prime? What should we get? Well, we should have it print out I, and the first two guys should be 2, 3, 5, 7, 11, and so on. So let's evaluate it. 2, 3, 5, 7, 11, and so on. So here we have all of our prime numbers. Great. We might even want to know how many there are, and we could sit here and we could count them, 1, 2, 3, 4, and that would be fine. But if we cared about a larger amount of primes, maybe this is not going to be the best way. So what I'm going to do is I'm going to show you a technique, and in fact, let's be a little bit specific. Let's call this number of primes, and we're going to set it to be 0. And every time there's a prime, what I want to do is I want to increment this by 1. So plus equals 1 means increment this value by 1. And then this will not get printed. It's just in the background, it's saying, hey, I have this variable. Anytime I see a prime, I want to increment it by 1. Okay, so it's going to see 2, and then num primes is going to be 1. It's going to see 3, and then num primes is going to increment by 1 to 2. And then it's going to see 4, and it's not going to run this logic because that's false. So num primes will not be incremented at all. And then it's going to see 5, and then it's going to be incremented, and so on. All right, so that's fine. Let's, outside of this, let's ask it to print num primes and see what the number of primes we found is. In fact, let's give it some some string here, the number of at most 2-digit primes. And in fact, I'm not sure if this is going to work because I'm not familiar with the print syntax, but we'll try it out. All right, there we go. Cool, it worked. So it still prints our primes, good. At no point did num primes get printed. It's just the same as before. And then at the end here, we have the number of up to 2-digit primes is 25. So if we sat here and we counted all of these, it should be 25. And I'm not going to do that, but you're welcome to. So so let's maybe recap what we just did. So we introduced the factor method on an integer. We saw that it would give you it as a factorization into prime powers. We introduced the isPrime function, which checks whether or not an integer is prime. And we also introduced this for loop, which it operates kind of like indexes do in math, because that's what it is. So you do I is equal to the start value, and then you increment I by 2 after that. Or so you increment I by 1 and then run the logic again, increment I by 1, run the logic again, and so on. So so we did that, and let me do one more thing here. let's say the number of primes less than, I don't know, what number should we pick? Let's say 1,000,000. I'm not sure if it can handle it, but we're going to try 1,000,000. And here, let's look at the range 2 to 1,000,000. And all we're going to do is every time we see a prime, we're going to increment num primes by 1. Now we wouldn't want to print them all out because this would be really big. But every time we see a prime, we increment it by 1. Okay. All right, now this should take a minute to load. Well, that was actually quite fast. The number of primes less than 1,000,000 is 78,498. And that's this is pretty cool stuff. We can check this with just a simple for loop.